What is up, stats nerds? I'm Professor Charlie Collins. Welcome to another feature of Current Mode, where we aren't mean, we're just average. Today we're talking about bivariate analysis, bi as in two and variate as in variable. Now, bivariate analysis is when we analyze two variables together. So today we're going to cover how to think about different analyses that use bivariate tables, which means these are statistics typically analyzed using nominal or ordinal variables. An additional video will show you how to run these analyses within SPSS. Bivariate tables are so called because they present the frequency of scores on two different categorical variables at the same time. Within these tables, the rows and columns each represent a different variable, which we typically refer to as an X and a Y variable, or alternatively, an independent and a dependent variable. The cells within the tables represent the scores or frequencies of the combination of X and Y variables. For example, we might be interested in whether political party affiliation is related to the support of a particular spending bill for voters. In the rows, we would enter party affiliation as, let's say, three categories: Republican, Democrat, and other. And in the columns, we would enter maybe two categories for bill support as do not support and support. Right? So each cell would represent the frequencies of each of these combinations, such as the number of Democrats who support the bill and the number of Democrats who oppose the bill, for example. Now, before we jump into our procedures, we need to understand why bivariate analysis is useful. Bivariate analysis is useful because they can help us answer three questions. First, does an association or relationship between X and Y exist? Two, how strong is the relationship? And three, what is the pattern or direction of the relationship? To determine which statistic to use, we need to understand our levels of measurement for both our X and our Y variables, or independent and dependent variables. So as a brief reminder, nominal variables are those where responses are categorized into non-ranking buckets, right? So gender, religious affiliation, political party affiliation, these are all examples of nominal types of variables. Now, ordinal variables are similar to nominal variables, but the categories can be ranked or ordered by the size or some other logical unit, right? So, for example, we could measure height by something like short, average, tall. We could measure something like political affiliation by conservative, moderate, and liberal. Or we could measure income by something like below 50K a year, 51 to 100,000 a year, and more than 100K a year, for example, right? So we can rank each of these categories in some sort of logical order. Now, while nominal and ordinal variables are considered categorical generally, interval and ratio variables are considered continuous. This is because the response options are numerical, they're ordered, and the distance between each of the units, or each of the buckets is the same. Right. So, for example, something like age, yearly income in dollars, and the number of hours spent on your phone are all interval or ratio variables. Now, just to note, the difference between an interval and a ratio variable is that ratio variables have a logical 0 point, right? So if I made $0 last year, that literally means I have no dollars, right? That's different than something like temperature, right? Where 0 in Fahrenheit doesn't really mean anything. Now, as a general rule of thumb, crosstabs analyze categorical variables and correlation analysis analyzes continuous variables. So if you have a combination of categorical and continuous variables, you want to use analysis of variance, or what we call ANOVA for short. And I'll cover this in another video. So let's first start with categorical variables using crosstabs. I'll start with chi-squared, which helps us test whether there is a relationship between variables, and then move into phi, Kramer's V, and gamma, which helps us understand the strength and direction of the relationship. You'll have the option to calculate any of these statistics in any statistical package under the crosstabs or chi-squared command. And they all have this option, right? And so an important thing to note about crosstabs is the output that's created. And as I mentioned previously, crosstabs produce tables of various sizes. depending on the number of categories in each variable. So, for example, if the x variable has 2 categories and the y variable has 3 categories, we would call this a 2x3 table. This is important because we often talk about crosstabs in terms of table sizes. Now let's jump into our different tests. Chi-squared is a test of independence, meaning it examines whether 2 variables are independent from one another or related to each other. In other words, it tests for a relationship between 2 variables. Are they related? Although chi-squared tests can look at tables at any size, it's really limited by sample size, right? So the size of your sample, and should not be used for tables larger than 5 by 5. And so sometimes you'll get an error in your output, and that's because one of these issues is violated, right? So your table's too big, or there's a cell with no cases in it, something like that. And chi-squared is also limited because it doesn't tell us the strength or the direction of the relationship, right? And so what we need to do is we need to rely on other statistical tests such as phi, Kramer's v, and gamma to tell us the direction and the strength of the relationship. And so phi, we'll start there, is useful for when you want to analyze 2x2 tables. In other words, the association between an x variable and a y variable when both variables only have 2 response categories. For example, I may be interested in the association between sex, measured by 2 categories, male and female, and political affiliation, measured by 2 categories, Democrat and Republican. Kramer's v extends this and extends phi by including variables with a greater number of categories. So tables that are larger than 2 by 2. So let's say that I'm interested in looking at, let's say, the association between race, and let's measure race by 5 categories, right? Let's say Asian, Black, Latino, white, and other. And support for affirmative action, and we'll measure that with, let's say, 3 categories, low, moderate, and high support. Now, this analysis would create a 3 by 5 table, and it would allow me to examine if there's an association between one's race and their support for affirmative action. And it also gives me statistics around the strength of that association, right? Now, although phi and Kramer's v are generally used when we have at least one nominal variable, gamma is typically used when both variables are ordinal, right? And gamma is nice because, and ordinal variables are nice actually, because it can tell you the direction of relationship, while the other two tell you the pattern. Gamma tells you the direction, right? And so gamma is really best used when both x and y variables have no more than 5 categories. And so again, as an example, let's say I'm interested in the relationship between income and political affiliation, right? And I measure income by 4 categories, ranging from, let's say, 50,000 a year as the lowest category and over 200,000 a year as the highest of the 4 categories. I'll then measure political affiliation by 5 categories, ranging from, let's say, very conservative on one end to very liberal on the other end. Although the difference between chi-squared, phi, Kramer's v, and gamma are subtle, it's important to understand the differences between them and really under what conditions they can be used. So any statistical software will give you results for any of these statistics, even if you use them incorrectly, because it assumes that you as the researcher know your variables and how they can be tested, right? So one of my graduate student advisors when I was in graduate school said, these programs are dumb and you have to treat them like they're dumb because they're very particular about the way the way you use them, right? So let's recap. Chi-squared provides us the answer to whether 2 variables are statistically related. Phi allows us to test the strength and pattern of a 2 by 2 table. Kramer's v extends phi and allows us to test larger tables when at least one variable is nominal. And gamma allows us to test the strength and direction of ordinal variables. Thank you for watching Current Mode. I will catch you next time.